Welcome to Part 5 of the CipherVibe Cloud Security Capabilities series. This episode explains Cloud Identity and Entitlements, why it matters, how the capability works, which mistakes weaken it, and how to build it in a measurable way. Cloud Infrastructure Entitlement Management analyzes who or what can access cloud resources and what effective actions those identities can perform. The challenge is that access emerges from users, groups, roles, policies, trust relationships, conditions, resource policies, and temporary sessions. The key idea is that a security capability is more than a product feature or a collection of alerts. It combines people, process, technology, decision rights, evidence, and continuous improvement. We will examine its architecture, operating workflow, failure modes, defensive controls, implementation roadmap, and useful metrics. Coverage is not the same as effectiveness. A dashboard can show thousands of checks while the capability still fails because evidence is stale, ownership is missing, or remediation is never verified. The business outcome should be explicit. Teams need to know which loss scenarios the capability reduces, which systems are in scope, and which remaining risks require a conscious decision. To understand cloud identity and entitlements, start with its architecture and vocabulary. The capability should create a traceable chain from source evidence to a security decision and then to an accountable action. First, effective permission is the action an identity can actually perform after all grants, denies, boundaries, and conditions are resolved. Second, human identities, workload identities, service accounts, federated roles, and external principals require different governance patterns. Third, privilege paths reveal how role assumption, group membership, pass role rights, token creation, or resource policies enable escalation. Fourth, usage analytics compares granted access with observed activity to identify dormant, excessive, or rarely required permissions. These concepts need shared identity, timestamps, provenance, ownership, and access control. Every summarized risk should link back to its source evidence and disclose missing information. A sound architecture separates collection, normalization, analysis, policy, workflow, and presentation. Teams can then test freshness, identity resolution, policy results, owner routing, and closure independently. Design for degraded conditions. Providers impose rate limits, schemas change, credentials expire, and events arrive late. A professional capability reports uncertainty and health instead of presenting incomplete information as fact. Trust boundaries deserve equal attention. Identify where data crosses accounts, tenants, regions, vendors, privilege levels, and administrative domains, then apply authentication, authorization, validation, encryption, and audit controls at those boundaries. A useful operating model for cloud identity and entitlements follows a repeatable evidence lifecycle. First, inventory identities, credentials, trust policies, group membership, role bindings, resource policies, and federation providers. Second, calculate effective permissions and map each identity to owners, workloads, environments, and business purpose. Third, prioritize standing administration, cross-account trust, public principals, unused credentials, and escalation combinations. Fourth, right-size access through group redesign, scoped roles, conditions, just-in-time elevation, and workload identity federation. Fifth, verify that applications still function and monitor for privilege re-expansion through templates or emergency changes. The workflow does not end when a ticket closes or an API returns success. Security closure requires fresh evidence showing that the risky condition is gone and does not immediately recur. Ownership should be established before urgent findings arrive using service catalogs, business applications, on-call schedules, and escalation paths. Prioritization should explain the influence of exploitation, reachability, privilege, data, business criticality, compensating controls, and confidence. Repeated findings should drive changes to secure templates, defaults, libraries, identity patterns, and architecture standards. Define escalation points for missing owners, disputed priority, failed changes, and evidence that suggests active compromise. Those conditions should move into incident or risk governance rather than remaining indefinitely in a routine queue. The fastest way to evaluate cloud identity and entitlements is to study how the capability can fail. First, a policy that looks narrow may combine with another grant to produce broad effective access. Second, dormant access keys and unused service accounts provide durable entry points with little operational visibility. Third, cross-account and third-party trust can bypass assumptions based on local identity inventories. Fourth, automated right-sizing based only on recent use may remove permissions needed for rare recovery operations. Fifth, long-lived workload secrets are copied into repositories, images, logs, and developer environments. These failures share a pattern. A local measure looks successful while the full outcome is weak. A connector, scanner, or repair can report success while coverage, exploitability, or recurrence remains unresolved. Measure whether the program improves important coverage, shortens exposure time, removes attack paths, and prevents recurrence, not how many alerts it produces. Exceptions need a reason, owner, compensating controls, approval, and expiry. Automation should reflect confidence, reversibility, blast radius, and business impact. Test both through controlled failure exercises. Correlate weaknesses instead of reviewing them separately. A moderate configuration issue, broad identity grant, exposed service, and sensitive data store may combine into a severe path even when no individual alert looks critical. A dependable cloud identity and entitlements program uses defense in depth. No single scanner, policy, gateway, or agent should be expected to carry the entire outcome. First, centralize federation, require phishing-resistant authentication, and minimize standalone cloud users. Second, replace long-lived keys with short-lived workload identities and bind trust to exact repositories, services, and environments. Third, use permission boundaries, organization policies, explicit denies, and separation of duties for sensitive actions. Fourth, implement just-in-time privilege with approval, duration, reason, session logging, and rapid revocation. Fifth, continuously analyze effective access, credential age, last use, escalation paths, and external trust. Control design should include preventive, detective, responsive, and recovery layers. Together, they establish safe defaults, identify drift, govern containment, and restore service. Least privilege applies to connectors, agents, orchestration identities, data stores, and administrators. Scope, separate, monitor, rotate, and test their access. Every control needs an owner and test strategy. Validate it with representative assets, negative cases, simulated attacks, provider failures, and rollback exercises. Integrate controls with engineering through clear pull requests, owner routing, reusable fixes, documented standards, and fast feedback. Preserve an evidence trail from detection through decision, approval, change, and verification. That lineage supports investigations, audits, lessons learned, and fair performance measurement without forcing teams to reconstruct history from separate systems. A practical implementation roadmap for cloud identity and entitlements should build trust before scale. First, begin with privileged humans, long-lived keys, external trust, and internet-facing production workloads. Second, establish ownership and eliminate orphaned identities before attempting broad right-sizing. Third, move workforce access to federation and workload access to short-lived identity mechanisms. Fourth, introduce just-in-time administration and automated review of privilege paths. Fifth, integrate entitlement findings with data sensitivity, attack paths, runtime evidence, and change workflows. The roadmap is incremental because a focused production scope lets teams validate evidence, ownership, workflow, and control safety before scaling. Useful measures include standing administrator count, long-lived credential count, and used entitlement rate, external trust review age, and just-in-time adoption. Give every metric a precise definition, data source, owner, and known limitation. Pair lagging indicators such as exposure age with leading indicators such as coverage, control health, exception expiry, and secure template adoption. Maturity means the organization can discover important risk, explain it, assign it, act safely, verify the result, and learn from recurrence. Review the roadmap quarterly. Changes in architecture, threat activity, regulation, business strategy, and provider services can alter both priorities and assumptions. Retire metrics and controls that no longer guide useful decisions. For more cybersecurity market intelligence, research, and educational briefings, visit CipherVibe.com. CipherVibe is operated by Cloudsectech LLC. This video is general education, not legal, compliance, financial, or incident response advice. Never access or test systems without explicit written authorization.